Go. Go. Oh.
So let's talk about the problem. If we want to calculate the combined time it would take my mother and me to flip 52 cards, we have to take this approach. We have to identify the individual rates. We can do this by calculating this rate at which each of us could complete the task individually, expressed as the number of cards flipped per minute. And we can convert that to a common unit. In this example, we're using cards per minute. Then we can combine the rates, and that would be the sum of our both individual rates, and that will give us our combined rate. Then we can calculate the total time that would take for the task by using the combined rate. Solution. Firstly, let's convert our the time that we got from the video to the nearest tenth of a minute. So as you can see right here, I have a Python code that enables me to convert the times that I got to the nearest tenth of a minute. I got 2 minutes 34 seconds and 4 milliseconds for my mother, and I got 1 minute 31 seconds and 26 milliseconds for me. Now let's see what that is in for the nearest tenth of a minute. So as you can see, that would be 2.6 minutes and 1.5 minutes. Now, since we have that, now let's move on to the solution for part B. As you can see, such that the fractions are easier to see, I have created an HTML for it. Now let's open it up. As you can see, to calculate the combined time for flipping 52 cards, we need to determine the individual weights. So 52 cards in 26 minutes, 2.6 minutes, and 52 cards in 1.5 minutes. Now, we can write this as a fraction, as you can see right here. And when we add these two fractions, we get our combined rate. And the total time it takes us to flip 52 cards would be 52 over our combined rate. And when we do that, that gives us 0.95 minutes. So that's the time that it would take us if both of us were to do the task together at our own pace. Reflection. I learned about the concept of individual rates and how these can be combined to find a collective rate of work. Understanding how to convert time taken to do a certain task into a rate, cards per minute in this example, and then using these rates to find the total time for a combined effort was a practical application of math for a real life scenario, which was really useful. This exercise enhanced my comprehension of rate problems, especially the one example from lesson 5.2.
Go.
Reflection. I observed that the combined time for my mother and me to flip 52 cards were actually around 50 seconds, which is around 0.83 minutes, or approximately 0.8 minutes if we went around that to the nearest tenth of a minute in the real world. This result is slightly faster than the calculated time of 0.95 minutes. There are a few reasons why this actual time might be a bit different from the calculated one. This might be a result of human error. My mother and I probably might have been a little off the tempo, or a measurement error. There might have been some error in measuring time. For instance, the stopwatch could have been stopped a bit early or late, affecting the recorded time. However, that being said, the actual time is very close to the calculated time, and that's what we want. So this is my solution for part T. As you can see, this is my mother's rate, which is 52 cards in 2.6 minutes, and this is my rate, 52 cards in 1.5 minutes, plus the rate of the third person is equal to 52 cards over 0.95 over 2. The initial time, or the time that we found in part B for both of us was 0.95, and we have to do that in half the time now. So that becomes 0.475. And when we combine our rates, we get 164 over 3. And when we take that to the other side and we subtract that from this fraction, 52 over 0.475, we get 3,127 over 57. Now this gives us a rate of 54.81 cards per minute. And that's the rate at which the third person has to perform their tasks such that we finish at half the time that we found in part B. The third person has to be very fast at a rate of 54.81 cards per minute. This means if they were to flip the cards alone, they would take 0.95 minutes. Coincidentally, the combined time of me and my mother is also 0.95 minutes. Uh, Reflection. Reflecting on the card flipping exercise, the math beautifully illustrates the concepts of rate and collective work. Initially, my mother and I flipped 52 cards in 0.95 minutes. By combining our individual rates of flipping, a clear case of teamwork outperforming solo efforts emerges. Adding a third person, the math requires them to work at a blistering pace of 54.81 cards per minute to slash the time to half, especially to specifically to 0.475 minutes. This rate is quite high compared to our individual rates of 20 cards per minute for my mother and 34.67 cards per minute for myself. The surprising result is that the third person's individual time to complete the task would match our combined rate. However, this makes sense if we go back to our solution because, as you can see right here, uh, we are dividing the time that we found in part B by 2. So what we're really doing here is we're taking this rate and multiplying it with 2. However, in this side of the equation, uh, n- the combined rate doesn't change; it stays the same. Therefore, to compensate, this has to become equivalent to the combined rate, such that this entire side doubles, just like the other side, hence in a way that is reasonable. Therefore, there is a reason that our individual rates of 20 cards per minute and 34.67 cards per minute is very close to the rate of the third person.